Nice question. Line touches a circle, so we've got a circle. It is touched by a line. So normally when we're trying to find out where these intersect each other, we know we'd be doing simultaneous equations. So it's the same thing here. Normally when we solve simultaneous equations, remember we get three situations. They don't touch, bit of a tricky question. They touch just the once, or maybe they touch twice. And remember these bits relate at some point to our discriminant. Discriminant being bigger than 0, discriminant being equal to 0, and discriminant being less than 0. So at some point along the way, we're looking for maybe a quadratic, and using our knowledge that we've only got one solution because it only touches the circle, so our discriminant we can put it equal to 0. So we're kind of thinking, got two functions that are touching each other, we're trying to think of simultaneous equations, and actually they only touch once, so I'm using this knowledge somewhere. So I can't believe this, but your first mark on this question you got from simply taking this equation and writing it as y equals mx minus 2. And then the next thing you need to do was shove it into this one. Sorry, I mean substitute it into that. So x squared plus 6x plus mx minus 2 squared. I think a lot of you are put off by the fact that you've got an m in there as well. Now, you just got to deal with it, I'm afraid, because if it didn't have an m in there, it would be a GCSE level question. So they've got to make it a little bit trickier at some point. So you can see, if the m is just a constant, which you know it is, it's just the gradient of this line, this is a quadratic. We need to get it into the form ax squared plus bx plus c equals 0 before we can decide anything about this discriminant. So we've got to expand it all, and it gets a bit messy, but you're all good enough to do this. So you're going to get m squared x squared minus 4 lots of mx, 2-bit twice, plus 4 on the end, minus 8 mx plus 16 equals 4. So we want to make this equal to 0, but I also want to collect my like terms together. So the terms I've got with x squared in, this one here. How many lots of x squared have I got? I've got 1 lot there and m squared there. So that gives me 1 plus m squared lots of x squared. The next thing I want to look at is my x's. I've got x there and I've got x there, and I've got x there. So I've got lots of x's. I've got 6 there, and I've got minus 4m, minus 8m, minus 12m times my x's. And then my boring old coefficients on the end, I've got plus 4 there, plus 16, and I've got that 4 there. Remember, I need to make it equal to 0, so that's just going to give me plus 16 equals 0. So now I've got my quadratic in this form. A, don't need a squared bit there, do I? A, B, and my C. So that's probably the hardest bit. The rest now is just using your brain. So it only touches a circle once. So we know the discriminant must be equal to 0. So b squared minus 4ac equals 0. So my b is all of that, the 6 minus 12m squared minus 4 lots of my a, 1 plus m squared times my 16 equals 0. So yet again, within a problem involving a circle and a quadratic equation here, I've made another quadratic equation here, so it's like a vortex of quadratic equations. Expand all of this, make it equal to 0, take your time over it carefully, and you get 80 m squared minus 144 m minus the 28 equals 0. Numerous ways you can solve that. You might want to simplify it a little bit more first. Or you can just cheat, stick it in your calculator. It's not cheating, it's fine. Okay, use the formula. It's not going to factorise, use the formula. And you get out eventually that your m values 9 plus or minus 2 root 29 over 10. Okay, not nice to look at, fairly gruesome, but very, very doable. Okay, 1 mark for making that little substitution. Everybody should have got that. 1 mark for putting it in. Sorry, 1 mark for rearranging, 1 mark for making the substitution. Getting your quadratic in this form where it's equal to 0. 1 mark. The knowledge to use this correctly. So these two lines give you your next mark. Forming a quadratic equation. So that is there. And then your answer down here gets you that next mark. Oh, I missed one out. You're solving a quadratic equation. So your method for solving, whether you use the formula or those who are really brave might have completed the square, but I doubt it. So 1 mark for how you solve that quadratic.